Welcome back. We're going to further our conversation on natural selection. Now, Google Classroom, I had posted a game with some moths, and you were the predator trying to select these moths. But many of you had some complaints or some troubles accessing the game, so I'm going to bring the game to you. And what I need is a bucket of mud. I happen to have a bucket of mud in front of me. In this bucket of mud are snakes of different colors. What I want you to try to do, and I'm going to pause the video for this, is to count all the snakes you possibly can. Ready? First pause. And we're back. How many did you get? I'm not going to quite reveal it. The next thing I want you to check when we pause again is which snake is most plentiful. What color? Are there more reds? Are there more yellows? Are there more blues? What is it? Ready? Pause. Reds? I don't know. You tell me. The actual answer for question 1 on this, there happens to be 15 total snakes in this entire bin. What? There's reds, there's yellows, there's blues, there's greens, and the most plentiful species in this entire bin are blacks. There are 5 black snakes in this bin. There are 3 reds, 2 greens, 2 blues, and 2 yellows. But 5 black snakes. Did you find all 5 yet? Take another pause, see if you can get them. Let me point out all the black snakes for you. Here's one black snake. Here's 2. Here's 3. Here is 4. Here's his head. And the 5th one was the trickiest. The 5th one is right here, dead center, underneath this little bit of rock. Now the reason I do this is because I had the salamander in my hand. I was talking about how camouflage, disguising itself to look like the mud, look like its environment, was a great adaptation that it developed through time to avoid predators. It was a variation in color. And all of these little play snakes have a variation in color. That's why you see all the different colors. However, one species is going to prove itself more viable for survival. And that's the black one because it was the hardest to see. If you're a hawk or a bird of prey and you're coming down to eat a snake, which one are you going to go for first? I'm probably going to go yellow and red and blue and green. And what I'm not going to get as often, and though some of you probably did find black snakes, what you're not going to do as often is choose the black snake. And so, if we have more black snakes surviving, less yellow, green, blue, and red, then the black snakes are going to be mating more often. Those black snakes are going to pass down the black color trait down to their offspring. And over thousands of years, we have this natural selection process getting rid of the bright colored snakes in this area, but leaving behind the dark colored snakes that fit into their environment. Those are now going to be more suitable to survival. So that's pretty much what the game was all about. What we want to talk about are the evidences that we can find for evolution. So how do we know this stuff is happening? And there are 4 different things that we're going to look at. The first one is going to be the fossil record. Now we've done one fossil video, and guess what? I'm going to do another one where I definitely find a full trilobite this time. That's my whole goal. But we're going to look at the fossil record. Now, all fossils that have ever been collected develop this fossil record, this database of extinct, current, and changing organisms through time. Now we look at time in a really big scale. We've done geologic time, and we talked about the Cambrian explosion, something that happened 535 million years ago. This was the start of most of all life. Now, there are organisms older than this that you can find in the fossil record, but complex life that was evolving, anything 535 million years and to now is what we're mostly focused on in our fossil record. Like in Ohio, we mostly find things that are about 350 to 450 million years old. So now, scientists can watch 3 things in the fossil records. They can watch a species emerge, its explosion event, it's coming on. They can watch a species go extinct, and we have 5 massive extinctions that we talked about in class earlier this year. And they can also watch species change or species adapt through time. Now I have a few examples, I want to bring them back out. This was from our first fossil hunting video, and we have this large brachiopod in this fossilized matrix, and we can watch the different species of this change over a 100 million year period. Something else I found recently when I was fishing was This fossil, and I'm not sure exactly how old it is, could be a couple hundred years old, could be anywhere up to 2.5 million, probably not, but it could be up to 2.5 million years. What is this? It's a horse molar. One of the coolest things I've ever found was this horse molar. It's one of the back chewing teeth of a horse's mouth. And we can watch horse species especially change, and they've gotten so much bigger in the last several million years, where horses were this almost like a miniature style, and they've grown and developed into something with molars this size. Pretty cool. The second thing we look at is early stage development. And I've tried to draw as many weird little creatures as I could. So we're looking at the embryonic stages of chicken, fish, turtle, and pig in an early, a middle, and a late stage of their development. So while they're in their egg. And we can see that, pig wouldn't be in an egg. So we can see that in the first early stages, they almost all look the same. And I can circle some characteristics that are the same. One, they all have the exact same tail. Mostly the exact same tail. For our consideration, it's the same. They also have the identical slits on their throats. So they have these patterns on all of their throats. As they develop in the middle and late stages, you can see how they start to take on their own species. The bird begins to have feathers or wings. The fish is developing gills. It's developing dorsal fins. The turtle is getting a carapace or a shell. The pig is developing quadrupedal legs, and they become their own. But in the early stages, we can see that they all must have shared a common ancestor that gave them this initial step. We can also see that body structure is something that we wanted to pay attention to, the way things are physically represented. So we have something called a homologous structure. And a homologous structure are similar structures related species inherit from a common ancestor. So here we have two very different species, a human like you or I, and a dolphin. And I've tried to draw the skeletal pattern in a dolphin fin and a human arm. Now the human arm consists of a humerus, an ulna, a radius, metatarsal or metacarpals, carpals, and then phalanges. If I look at the skeletal structure of the hand, the forearm, and the upper arm, it matches really closely with the dolphin. We have an upper arm bone, we have two forearm bones, we have carpals, and we have phalanges, all in a fin. It's almost the same structure skeletally. Now, the thing about them is they have completely different functions. Whereas a human's arm is very dexterous, it's used for grasping. A dolphin's flipper, or fin, is used for propulsion in water. Different functions, similar structure, common ancestor. They all link together. The last factor that we use to talk about the evidence for evolution is the DNA and protein structure. And what we use this for mostly is it ties all the dots from the other three evidence categories. We already know things are starting to look alike or changing through the fossil record. We can see the development patterns. We can look at the physical structure of the organisms. Now we can test it. We can measure the amino acids, the specific amino acids in protein and DNA to see what things match up. Now, when we do this, we can say that a dog is more closely related to a wolf than a coyote based on the protein structure, the amino acid structure inside of that organism. So it helps us connect and tie all of these things together to prove that yes, the species is taking inherited traits, developing them, changing them, best suited for their environment, and then becoming a diverse population of chickens, fish, turtles, pigs, humans, monkeys, everything else in between. And it's a great thing. So that is a little recap on the natural selection video that we just did last week. We have these new 4 functions of evidence for evolution. And we're going to have also a supplemental sheet on Google Classroom for you guys to follow up on all 4 of these concepts. Hope you guys enjoyed this video. Sorry for bringing dirt into the house and Caleb. But hope you guys have a great weekend. See ya.